Functions are sections of code used within a larger program to perform a particular task. They're also known as procedures, subroutines, and subprograms, since they really are just mini programs within programs. Even though you might not have noticed, you most definitely have used functions already if you've programmed in C. When you write stuff to the screen using printf, you're actually using a function called printf. Likewise, getInt and getString are functions that CS50 provides for you. As programmers, we use functions for a number of reasons. Having functions to perform common tasks like writing to the screen and prompting the user for input saves us time when programming. It's not necessary to write code to do those same things, since they're already done for us. And it's not even necessary for us to understand exactly how those functions work internally. Instead, we just have to know how to use or call them in our programs. It's also helpful to write functions in larger programs, even if you're not planning on having others use them, just to divide up the larger task at hand. This way, you give structure to your code much like you'd give structure to an essay. And with really large projects, you enable multiple people to work on different parts at the same time, since it's clear where one person's work ends and another's begins. Functions typically operate on one or more inputs, known as arguments or parameters, transforming those inputs into an output value that is then returned. However, it's also possible to have functions that don't use any input arguments and don't return an output. Okay, enough with the fluffy stuff. Let's take a look at some real functions in C. Here, we have a function called square that, believe it or not, computes the square of the input. Let's dissect the syntax a bit. The first word you see in the function, int, specifies the return type of the function. That is, the C type of the function's output. This function will output a value of type int. The next word you see is the name of the function, square in this case. Naming functions appropriately is particularly important, since it's probably the most visible documentation of what the function does. It might be cool to name this function Shazam or Booyah, but that wouldn't tell us anything about what the function does. Following the function name come the inputs to the function, the arguments. They're listed inside a set of parentheses with both their type and a name to use for them within the body of the function. Square takes just one argument, the int to square, which I've decided to give the name x. This ends the function declaration or prototype. The curly braces surrounding the rest of the function denote the beginning and the end of the function body, the definition of the function itself. Square is a pretty simple function. It's only got one line, since all we have to do is multiply x by itself. The word return specifies the output value and triggers the end of the function. To use the square function, we need to supply the appropriate inputs and then capture the output. Here, you see a couple ways of doing that. We can pass in a raw int, like 6, or we can pass in a variable like a. Note that each time we call square, we capture the output in a variable and then print it. However, we don't have to store the return value in a variable and then print. We can just send it directly to printf, as we do when we square 10. But this does mean that we don't have access to the return value of square 10 elsewhere in the code. Let's look at another simple example. This time, we'll sum two floats together so that we can see what a function looks like when it's got two inputs instead of just one. As you can see, it's not much different. All we do is add in the second argument, a float named b, to the argument list, using a comma to separate it from the first argument, float a. So our square and sum functions are pretty easy to understand because they're equivalent to functions that you've seen before in math class. Now, let's look at a function that is slightly different. Instead of returning a value, it modifies state. This is known as having a side effect. In this program, the printf fud style function has a return type that we haven't seen before, void. Void is used to say that a function doesn't return anything. There are no variables of type void, so if you try to return something from a function like printf fud style, the compiler will yell at you. Inside printf fud style, we see that while the function still performs a task, namely switching all r's to w's, the point of the function is to modify the string and then print it out on the screen, changing the state of the program instead of returning a result. Using this function is very much like using our square and sum functions, except we don't store the result in a variable or pass it off to another function, since there is no result to speak of. So when we compile and run our Elmer Fudd program, you see that you rascally rabbit gets transformed white to you wascally wabbit. And finally, there's one more function worth discussing, since you've been using it in every C program you've ever written, main. Main is a function much like any other. It's got a return type, a name, a list of arguments, and a body. The return type of main is always an int, and this int is used to communicate the status of the program when it finishes. Did it run successfully, or did it end early because of an error? Returning 0 indicates a successful run, and returning any non-zero value indicates an error. Depending on the kind of program you're writing, returning different codes for different errors can be helpful for people who use your program later on. Main's arguments are a little more complicated. The argument list can either be empty, which we indicate by writing void in between the parentheses, or the list can have two arguments, an int and an array of char stars. These are used when your program intends to use arguments passed in on the command line, when the program is invoked. The int argument is typically called argc, and it's equal to the length of the char star array, known as argv. Argv contains the command line arguments passed into the program. In another short, we'll talk about how to use these variables in more detail. For now, you can feel free to declare main either way. I typically choose to write it out the shorter way, with no arguments when possible. Now that you know how to write functions, you're well on your way to developing larger, more complex programs. My name is Nate Hardison. This is CS50.